All right, this video is going to help out with lab number 4. Let me first apologize with the sound quality. I'm working with the materials that I have at my school, my high school, so I apologize again for it. So we have Stellarium open right here. You can see how I got the sun centered over the south marker. My ground has disappeared, everything that's described in the lab. There's the moon, I have it selected, and I got all of this stuff onto the left-hand side. So some of the things that you're going to find is the right ascension, which it doesn't matter which one you use as long as you're consistent. So I usually use the on-date one. You have the constellation that it's in. You have the distance. The distance, you probably want to have it in kilometers. If you write it in astronomical units or have already wrote it in astronomical units, then you'll just have another conversion factor that you'll need to put on there. The illuminated percentage will help out with trying to figure out what kind of phase it is. Thinking about if it's half illuminated, then that's going to be a quarter phase. If it's less than half, a crescent. If it's more than half, then it would be a gibbous phase. So that's kind of how that's set up. So I'm going to come over here to Excel. I promised I would help you guys out with the data logging here because it can be a little tedious. So I have my date, my hours, minutes, and seconds for my right ascension. Notice how I have them in separate columns, and then my distance in kilometers. So you have to do some calculation, and doing it by hand would be really tedious, and you're already going to have to graph this data anyway. So let's just figure out how Excel can do this for us. The first thing you have to do is convert your right ascension into just a plain decimal, not minutes, not seconds, just a 3 point whatever, 8 point whatever. So the way that we do this in Excel, now that I have this kind of all set up, I'm going to write an equation to help me out with it. So I'm going to start off with the equal sign. Then I need to have this, my hours, and then I'm going to add to that. So I've created a plus sign. Notice how it's B3 plus. And now I need my minutes. But here's the thing, is that minutes, there's only 60 minutes in a degree hour, in an hour for right ascension. So I would take my minute marker and divide it by 60, and that's what gets added to the full right ascension decimal. And then I have to do the same thing for seconds, but there's 60 seconds in every single one of these minutes, which means there is a total of 3,600 seconds in an hour, right? 60 seconds for every minute, 60 minutes in an hour. So then that means I would add my seconds divided by 3,600 and close my parentheses. So what I have is B3, the hours, plus C3, my minutes divided by 60, plus D3 divided by 3,600. And again, take a look at where my parentheses are. If I hit enter, I've created a decimal. That's my right ascension decimal. It's taken out to about 4 decimal places. It may calculate more, so you can always use one of these buttons up here to adjust the number of decimals. Now, one way that you can copy this all the way down, of course, you're going to have a lot more data than what I have here. This is just a small subset to get you started, is you can click on the bottom right corner of this and actually double click on it, and that copies down your cell for every single one of your data rows. So there you go, your calculation is done. You can copy that into the table that is in the Word document. Okay, the next thing is the heading. So the heading is going to tell us how we need to plot it on the polar axis. So if you read through the lab, the heading is taking your decimal right ascension and multiplying it by 15 degrees per hour. So we'll set equals, again, to start an equation. We're going to come over here and click on the decimal right ascension, and then all we have to do is multiply that by 15 degrees and hit enter. Now I already have this set up to not show me no decimal, or to not show me any decimals, so I can always make this more decimals, but we want it to the nearest degree, so I'll take it all the way down. Now this one's not sitting next to any other data points, so double clicking is not going to do anything, but I can click and I can drag that all the way down to get my heading degrees. Now we also need to know how far out we're to put our dot when we do our polar coordinate graph. So if this gives me the heading, this gives me the degree that I'm going to go out, but I need to know how far out the moon is relative to the Earth, and that's where this distance comes in. So it's distance in kilometers. If you read through the lab, it says that we are going to say that 1 millimeter is equal to 5,000 kilometers. So again, I'm going to say equal sign, and I'm going to take my distance in kilometers, and then I'm going to multiply it by the conversion factor of 1 millimeter divided by, and I need to have a multiplication symbol in there, 1 millimeter divided by 5,000 kilometers. And once I hit equal sign, there you go. So for this very first one, I'm going to go at a heading of 50 degrees and go out a distance of 76.5 millimeters. And if I double click on that, it takes it all the way down. Notice how the distances are getting shorter. That means the moon's actually getting closer. That also means that the moon is not in a circular orbit. It's in a little bit of an elliptical orbit. It doesn't fluctuate too much, but it does fluctuate a little bit. So you would do that for all however many days you have, more than 30, because you're going more than a month, and hopefully this use of Excel will kind of speed the process along. You could just copy this into the Word document that you're going to eventually submit, and then of course you have your graph. You do have a little bit more to do on the graph. There's a couple measurements that you're going to make to see how well your scale matches up to reality and calculate a percent error. Please Google the formula for percent error if you don't already know it, or you can always ask me how to do that. Actually, it's given in the lab. I'm looking at it right now. So if you have any questions, please let me know. Hopefully you've already gotten started on this lab. I've already gotten a few questions, and I think this will help speed the process along. Good luck, guys.